Hello there, children. Today, we are going to work on section 3.3, properties of logarithms. So, now that we've done some graphing of logs, we're going to work on properties to put them together and split them apart and work with them algebraically. Alright, so the first property we've got is what we call the product property. And as you can probably guess, this deals with products, namely speaking the following. It states that if I have a log base any b of an x times a y, I can split that up into two separate logs with the same base b with addition. So log base b of x times y equals log base b of x plus the log base b of y. An example of that, say log base 7 of t times m would be the log base 7 of t plus the log base 7 of m. This is what's called expanding. These properties also work in reverse. Namely, if I had the thing on the right side here, I could put it back together with into the thing on the left. So that's property number one. Property number two is the quotient property. Now, as you can probably guess, quotient deals with division. So, we have the log base b again of some x divided by y. I can split that up with subtraction. Log base b of x minus the log base b of y. Notice that the numerator is on top here, and that the denominator is the second thing. Example being log base 7, again, we can use any base, of a divided by d, log base 7 of a minus the log base 7 of d. Now notice here as well, the log base carries through both parts of the problem. Alright, so the next property we have on our list is what we call the power property. This deals obviously with powers. So what we have is this, the log base b of some x to the n. We can simply drop the exponent out in front like we're chopping down a 3. Thump! Down it falls out in front. Log base b of x. An example being this. Log base 71 of x to the 9th equals the 9 log base 71 of x. The 9 just comes out in front as a coefficient. Now note, these properties will work for any legal log base. I mean, obviously remember we talked about no negative bases. So what that means is, this includes a log base e. So these properties will hold true for ln. So what that means, I dealt with log base b for the last three properties. But remember, they will work if you're, instead of a log, if you have an ln instead, if your log base is e. It's very important to remember that. We can also work to expand or condense logs. Remember I mentioned our properties work both ways. Our properties swing both ways. They can go one or go the other. So they're a switch hitter. They can go expand or they can contract, which we will do both when we get to solving later on, because we'll have to do both in order to solve problems. Right. Alrighty, so expand the following two logs. Now, the first thing I do in expansion is I've got some options. The first thing for this problem in the blue here is I am going to split it up with addition. See, it's multiplication right there, so I'm going to rewrite it as addition. Now, luckily for me, my log was base 10, so I write it like this. Notice the addition is used because I have a multiplication in the middle. Now, is this fully expanded? No, it is not. I have to drop my exponents down in front like they are coefficients. Now, is this now fully expanded? Why, yes, it most certainly is, because I have all my exponents down as coefficients and it's spread as far out as legally allowed. Now, for this problem over here, you've got some options here. You've got two ways of doing this. I'll show you both. First way is, you know what I'm going to do? I am going to distribute that 7 in there first, just so I don't forget about it. Then I go, alright, your division, you get split up by subtraction. And then I go, hello exponents, down you go, splat, splat. Sound effects optional, of course. So we've got both. And boom goes the dynamite. Don't forget your 7 there. Spread out as far as I can go. Option 2 is you go, you know what? I'm dropping the 7 out in front first. Not bad. And then you go, I'm splitting this up with subtraction for its division. Here's why I'm showing this way second. Because that 7, when you split it up, ends up having to go to both of them. And the common mistake, as you can probably figure out from now, is you give it to the front one, but forget the back one. It's sitting there going, don't you forget about me. Distribute coefficients. So don't forget that. I prefer the method in the burnt orange over here because you're less likely to forget coefficients, but the choice is yours and yours alone. Alright, now we can condense the following logs, bringing them back together. Now in condensing, the one thing we're going to work on here is we have to first bring my coefficients back up as exponents. This one doesn't have a coefficient. This one did. The 3 hops back up, still subtraction. And subtraction now, we use the product or the quotient property to bring them back together. It's subtraction, so that means division. 1 log to rule them all. That goes in the denominator. Over here in the burnt orange, do I have the same base? Yep, so I may proceed. I bring these back up as exponents. As such, now what I do with those exponents, they're good. Plus sign, bring it back together with wonderful and glorious multiplication. Now I will say this. Remember a little bit of a side note here. You could also write it as this. The order doesn't matter, but you could write q to the 3rd and then the square root of x. Here's an important little caveat, folks, that you've got to remember. The square root of x equals x to the 1/2. Like the cube root of x equals x to the 1/3. So if you ever see these in problems that are expanding, they actually have fractional exponents that you must actually deal with. You can't leave them alone. Here, it doesn't matter which way you write it. If you write the square root or you leave it as x to the 1/2, both are mathematically equivalent and thus mathematically correct. So hooray for that. Now, for some of you with fancier calculators, use your calculator to please find this following value. The log base 4 of 7. Can we all do this? Now, if you have a newer calculator, certainly you can use the math feature and type in a different base. And if you do it in your head, beep, bop, boop, you get approximately equal to 1.4037. Hooray for me and hooray for math. If you can't do this immediately in your calculator, you need a formula to change the base. And it's all about that base. So let's work with that. So there has to be a way to change it to base 10 or base e, one that everyone's calculator, no matter how, if it's scientific, how simple it is, can do. Well, it is. We call it the change of base formula. Shocking, I know. Here's how it works. The log base b of x. You can write it in multiple different ways, but the way I'm going to write it is this. You have the log of x over the log of b. The base goes in the basement here. Draw like a little division bar right there. Base always goes in the basement, so I change it to base 10. Or I could use what other base? Base e, or ln. So the ln of x over the ln of b. Now I could pick whatever base I surely needed, but why would I pick something my calculator can't do? Now notice the ratio. If I'm using log, I stick with log. If I pick base 10, I must stay with base 10. The argument, that x value, it's called an argument again, over the base. Argument over base. Now it's very important here. If you use log, you must stick with log. If you use ln, you must stick with ln. You can't mix and match like a sale here. Like I can't do log of x divided by ln of b or ln of x divided by log of b. That's not going to work for us. So let's do an example. Now right here, log base 4 of 7, I can write it as one of those two ways, which, as we found out earlier, was that particular value. Now, we are able to expand and condense, and we are ready for the homework assignment, because we need to expand and condense in the homework, because we will need to do that in solving in the next section. So, oh, happy days are here again. Hooray, math. Woo! Yay, math. Let us do, go henceforth and do.